here today checking out this 2-inch shaft, and I'm just setting 0 here. Let's check this out. Oh shit, I'm gonna need a longer indicator. Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we have a shaft up here, and we've had this shaft up here for a couple weeks in this area here, and this is actually a personal friend's shaft. This is a piece of material. We're putting together a boat, and he was wondering if we could use this piece of material, and we were checking it all out. We die checked it, make sure that it didn't have any cracks, and I thought we'd take the bend out of the end of this. All right, now we have already pressed a little bit on this, and we've created a jig that we're working on developing to help us straighten the shafts where that bend is right between the major diameter of the taper and the cutlass bearing here. And we're kind of got our mind thinking just like we did on the rock we built for straightening struts, where you can grab the palm and then push in another position and put a dummy shaft in the cutlass bearing and recreate that hit that it had with the rock. We want to kind of redo that kind of thinking on the shaft, and we're going to develop it. So we've been starting to play with that. We're going to be showing you actually some shots of us building the jig itself, and a couple shots of using it in the press and getting it. This was running out a little bit more than it is right now. It was over a full inch of run out, and right now it's down to about 800 thousandths run out. Now we've decided right off the bat that we weren't going to use this after I did the shaft check, because the magnet sticks to it. It's Aquamet 17, okay, and I'm going to have to probably put some heat on this in junction with the jig to create, get the bend out of this thing. So we have another piece of material over here, and we're going to bring this on over, and we're going to talk a little bit about this project and 2 other projects that we got going. We are slammed with shafting work right now, and we have a couple other things that have been going on in the shop with these other shafts that are out of the ordinary that you may not come in. Most of the time people got their coupling off, they bring in their shaft, the coupling, they want it checked out, and the prop, maybe that lapped on. So here's a couple things that just happen along the way while you're in the shop repairing propeller shafts. Alright, here's the slug for this 2 3/4 inch shaft. We had a heck of a time pressing this out of the coupling. It looks like it was really hitting hard on 3/4 of the lower half of the taper, and there's a area in here where it actually shows that moisture got in there, that there was no contact, but yet the break happened slightly above where the coupling was setting. It did have a stainless steel key in it. The key was bound into the coupling. It took a while to press it all the way out. Here's a few shots of what we had to go through to get this out of the coupling. Okay, got this coupling, got a nut holding the shaft on. The shaft was broken at this end, and they dropped it off here, so it's my job to get this apart. So I'm going to show you how to get your nut off on a Monday morning here. Alright, I've got 2 parallels here, and I got hole patterns drilled in them, and I happen to have 2 here that match up, and they match up pretty close. Alright, and we'll go ahead and we put these are grade 8s, 1/2 inch. That's what I use when I want the extreme holding power for my project here. Alright, and we'll whip these on here. Alright. Now we're going to use a hydraulic press to actually hold these parallels, and I think I'm going to put one there. I think I got a block here because I know that spacing, the ram doesn't come down all the way. Yeah. Okay. Okay, now we're locked down here, just like it's in a vise. All right, Marina gave me a socket, and it's just a regular, typical automotive type socket. Gets in there, and then we can. We're gonna need a little bit more than that. Okay, we're just twisting the coupling onto the bolts. We've just about got that, but that's not going to get it there. Okay, now we get a little bit of leverage in here. I think that's like 200-pound torque. I may need to gain some weight. E-bomb, I need help. Okay. So much for the foreplay. Okay, we did get the nut off. It did take heat. Most of us knew that if I couldn't pull on it with the small cheater there, that it would take some heat. Because this thing, actually, you can see in here that there's a buildup and flake of rust in here. Sometime or another, this coupling was below waterline, and so it, you know, it just really shows that sign that I don't know if it was completely submerged, but at least a portion of this shaft was submerged, and then salt water got in here, and it pretty well toasted up everything. All right, and after we heated up and we were putting some more shit on it, the square end here came off of our little Chinese wrench here, and put a little bow in it. So, but that's all right, because we had this one here, and we've had this one since we were in the shipyards, and this has got me out of a jam and lots of time. This one here is made in Japan. So the Japan ratchet was able to withstand my punishment I was putting on it. I do have a breaker bar. My breaker bar that comes in this 3/4 inch kit is only about 3/4 as long as the ratchet, and I'm not hammering or breaking on it, so you know, the straight pull to me is okay on a ratchet. I mean, I'm asking it to do a lot, but I'm asking it. All right, so we got this hub in here. That's the broken off in there, and that's the direction it's got to go. The nut holds it up this way here. So let's fire up the press and let's press this out. My belief is that this shaft and this coupling is loose on this shaft. It may be rust in there, and it may actually have a little bit of binding from the keyway, but this thing really shouldn't take too much press to get this out of here. Well, she'll stall out my press. Alright, we're going to go get some heat. I'm going to put that around here. Okay, this is usually when you have all this stuff all over the top of your table here, and this thing pops. It elevates them. Some of them actually leave the top. Some of them stay. Some of them shake. I don't know. We'll see. Maybe. I wish I knew exactly when that was going to happen. I'd put it on slow motion so we could actually see that part. But, all right. So, I went, got my heat here. But I do want to try one thing here just before we slap the heat on there. Sometimes a shock, such as hitting it with a small hammer, would break it loose. So we're going to give that a try. I'm going to fire this back up and get some tension on here. And if it doesn't go, then we're going to fire up the rosebud, and we're just going to equally put that all around. All right. I will move these out of the way here. All right. Everything else can stay. Okay, that theory's been proven not to work on this case. Equal, even heat. We got her. And I told you some stuff was going to come off this press. Looks like things were up above. My little helper hammer did. We had a magnet there that didn't stick. And another one here. Looks like everything else a little misarrayed there. Alright. I'd be curious to see that slowed down. Oh, and it stalled out my press. Huh? I'm gonna have to hit the reset. Alright. That's gotta be key bound, okay? It's a taper bore. Once you break it loose, okay, that's all the way down even. Okay, it only took 2 seconds here, and the key is stuck in there. That key was frozen solid. All right, we got the rest of the puzzle out here now. Yeah, it actually galled the keyway coming out. All right, this is the good used piece of material, and I've already cut off the excess ends. Some of it had wear on it, and some of it was just it was tapered on both ends, and we got a shaft that's going to have a straight coupling on one end and a taper on the other end, and dripless seal in the middle. So we had to shift that around to incorporate everything that's important in on the new shaft material here. It's a used piece of shafting, but it's gonna be brand new when I get done with it. So anyway, we still have that Aquaman 17 sitting here, and this is the jig that I actually built that we're working with, and this will go on, and it has a rocker rod at the bottom and a pushing point right here. The idea behind this is because when you have extreme bends, when it bends, it stretches one side and it compresses the other side, and you need to bend it back, and you need that to create that same thing. If you just take and put a block underneath here and a block over here and put your ram here and push it, you have a certain amount of forces and stuff, and this actually has a keyway on this bottom side here, and you could be mushrooming and bending, and I mean, even if you have aluminum in here, you can still get some deformities. And also too, you could get somewhat of a reverse bend underneath your tapered area, and you don't want that. You might have a little bit that you're going to have to lap fit and stuff as it is. So the jig is made to slip over the taper and keep the taper's integrity whole, and then get the bend in there. And this jig is basically to get this back into at least, you know, within under a 32nd of an inch, and then I can go into heat straightening. But this amount of bend in here, and what we've already seen in the hydraulic press, which will bring you in and actually show you what work went into creating the jig, and also its first run in the press to take out some of this bend that we've already taken out. Okay, we're in here and we're actually using our tracer attachment to go ahead and bore out our rock jig, and it's hydraulically controlled. I just wanted, this is the lever, I control it from this side here, but when the finger comes in, the finger down here hits the pattern, and that's what controls that. Now this doesn't come straight in, it comes in at an angle, so that allows you to come down and hit profiles like faces and radiuses and things like that, and it just reads the surface that you got down here on your pattern, whether it be a cylindrical pattern or a flat pattern. Okay, now let me bring you into another position there so you can actually see it. We're almost finished with our bore. We got a couple more cuts, but I wanted to bring you in so that you could see what we're doing to make the rock jig. I've got you on the back side here, kind of getting an angle that we don't show too often, but you can see the stylus right down here. Stylus is the finger that comes in, and actually that controls the hydraulic motion. Okay, so that's going to follow the pattern here, which the pattern is just a standard 3/4 inch per foot taper. Now, one advantage of tracer attachments is the setting up the pattern between 2 points. On a taper attachment, you have a center pivot, and then the angle pivots off of that one side. You can actually create a 0 at one side and give the full indication of lineal travel off the whole length as 1 per 1. But when you're doing a taper attachment, you've got to take that and divide that by 2, because you're pivoting off the center if you're going to read off the indicator or read off the scale on the side. All right, so you're going to be able to see the stylus, and you'll see me pull the handle, everything move in, and then the bar gets ready to go inside. All right, let me go around the other side here. This is our main gauge here, and this goes from 1.5 to 2.25 inch shaft. That's what this range is on this one here. I have a smaller one, and I've made a bigger one for other shops, but I don't have one here. And I'm keeping track of where I need to go. So I need to pick up about 3/4 of an inch there within a couple cuts, and we've been sneaking up on that about 20 thousandths. A pass gives us just a little bit under 1/2 inch of lineal travel. That's per side, so yeah, that's what we're dialing in here. All right, we bring that in, we go ahead and start it up. We're just coming in and just basically touching, making sure that that's where we were. Okay, and we go ahead and we're going to take 20 thousandths here. So we just advance our cut with the in and out, straight in and out. It actually feeds at a 30-degree or so angle here off of the face, so that it can handle a face cut or profile, like I said before. Now we're going to let that run all the way through there, then we're going to check with our gauge. I'm going to bring you around to this side here so that you can see how I'm fitting the gauge and into the bore. Okay, we just finished the cut here, and we hit the hydraulics to force our tracer back out of the way. It gives us this whole area right here. Now we pre-marked, because we measured the length of this and our 2-inch mark there, so our mark that we're hunting close to is this mark up here. Alright, we are pretty close right at that mark there. So we're going to double check, we're going to get a light, we're going to look down in the bore there. We feel it doesn't rock, so we feel good. We might take a spring cut on there, just so we can smooth up the bore a little bit. That actually looks pretty good. We may just leave it just right there. This is a jig that's going to force bending. We're going to be welding on the outside of this. I think we got what we want out of this bore right here. All right, we're going to be breaking down our assembly, and we're going to get this out of here. And we might put another chamfer here, face it, and chamfer the other end there. Then this is ready to go into be welded. We have some cutouts that we got to create on the plasma cam, and then we'll be coming back to the hydraulic press and grabbing our shaft and actually bringing some of that bend right out of there. Okay, we just finished end milling the tube for this 1.25 inch to go through, and we just got this set in here because we want to space these things out for the 3.5 inch width. And we have this round piece, and that's what the ram's going to come against there. So what we're going to do is we're going to tack 4 places or so on that shaft down there, and we're using our MIG here. We're kind of low on gas, but I think we got enough to do this whole job. Nothing real high tech about this. Alright, so I'm going to go ahead and tack this a few places here. I just kind of eyeballed that square. I didn't really put a square on it. Alright, while we're here, and it looks like we're pretty even for this 1.25 inch, I'm going to put a couple tacks on it here as well. Okay. Alright, now we're going to have 2 pieces for right now. And I'm going to get 2 more tacks on there. And we'll put some tacks in here. Okay, this is the minor diameter. This is the way this is going to go. Just about like that. And we're going to go ahead and we're going to force this down for a halfway fit here. There we go. Okay, now we gotta get this even here. So we're gonna let it rock on this one here. Okay, those look good there. Those look good there. Let me eyeball that. This has got to go down just a little bit. I gotta go get my rawhide mallet. Okay, I'm having to hold the angle of the dangle here, and I think that looks pretty good right there. I might be able to adjust it after a tack or two here. Okay. Okay, I like that, but I'm going to have to put a clamp on this to bring this in. Okay, here we go. Okay, there's the rock. Shaft goes in there, nuts go on here. It'll actually be angled down like this. We put the press here, and we support underneath the bearing like the strut bearing's in there, and we bend that shaft back. We're all set up here, and I have multiple cameras in to catch this from other angles here. I got the fan going. I'm not going to shut it off. I got fans going on through the whole thing. We're 84 degrees inside here. We're having one of the most humid days here today on the Cape. No complaints. Hey, it's not snowing. So anyway, and thanks, Kevin. At least the ice never melts out of my cup here. All right, I think we're just about ready, and we're going to bring you in just a little closer. 3 different angles here, and we're going to go ahead and start straightening this shaft. Okay, we have this underneath here. Now we angled this back here a little bit, so when that ram comes down here, it's hitting back here. As it rotates, it will slide across the bottom. We're holding our scale here, and we're looking actually where our bend is here, and where it takes off, and that's why we place this. We have this distance or this height kind of planned out. When we press this down, we're going to be coming down to this, and you'll see an open gap up here, and then as this pivots, we'll be laying it on down, and we'll decide how far we need to go. But we're going to use this up here on the top, and we're getting down eyeball with it. And we know that this shaft here is about a 1/4 inch below the scale. All right, so we ease this down. As we're easing this down, we're watching our ram up here so it doesn't pop out on us. Pretty stout little shaft, huh? Okay, that was enough to break our weld. Okay, now this last little 1.5 inches here, these just came in yesterday, and we have a piece of shaft coming in to make a new one. This is the coupling, and the coupling on this case right here. broke off right at the face. This is like a V drive. And anyhow, this was not lapped or fit on here, and it only has a couple little minute spots on it. Alright, and they are just showing that there wasn't enough contact in here, and this thing got loose and then started slamming. The side of the keyways actually show remnants or marks of the key slamming. And I'm staring in here, and we actually have a crack developing in on the coupling as well. Alright, on this 2 3/4 inch shaft, when the coupling in broke loose, that shaft went sliding back while it was rotating and connected up with the rudder. And when it connected up with the rudder, the force, the side force, played a part in pulling the strut out of position. So we have the rudder here and we have the strut here, and here's a few glimpses of what we've actually had to do in getting those back straight. Okay, this is the rudder that goes along with that 2 3/4 inch shaft we're working on that broke behind the coupling, and the shaft and wheel went back in, and we've pressed a little bit of obvious bend out of this, and now we're getting ready to nitpick it. Well, because we have a side fin here and it tapers in here and then becomes straight after that, we want to, we work straight edges along the surface and stuff like that. Now you can stare down through here and you can pretty well line up down this sight right here, and then you'll see that it takes a bend and comes on over. Now when we straighten a rudder, we're straightening it so that the rudder blade and the stem are straightforward to each other or in line with each other. And we have side to side, but we also have forward and aft bend to investigate at the same time. Now we've cleaned up the stem, we straight edged the stem, and it looks pretty good. And also we check it to see if it is bent forward and aft at the same time as we are going side to side. But we're going to work side to side first, and then after that, then we can control forward and aft bend. We made this jig up on the plasma cam and show you that cutting out. Okay, here we go. This is 111 inches a minute. This is 16 gauge, 60 amps. I'm running about 50 amps on the machine, but it's a 60 amp tip. Gives me about 80,000 surf. All right, gotta move it kind of a way here. Okay, this is gonna go against the rudder stock, and this is gonna reach over the blade, and this is gonna point at the center of the bottom of the rudder. We're gonna take it in here in a minute and we'll show you it being used, or at least set it up so you see how it's being used. Okay, so the jig, actually this is a straight edge along the outside of the rudder post, and then this is clearance to get past this, and then the little point here actually shows 1 inch in from this, which would be center line of the shaft. Pretty straightforward. So you hold this up here and you can see, you slide it back here, and you can see that we are off almost 5/8 of an inch. And to verify or calibrate this, when you turn it around and you put it on this side right here, you're at that same distance to the one side. All right, so this bottom needs to go that way there, and we can see that bend almost focused right here as far as taking the straight edge down here. There is a couple good dings right here where that blade kind of whacked it a little bit, and so we're going to go ahead and take it in the press, and then we're going to be coming back over here and setting it up so that we can hold the jig in here until we absolutely get the bottom of that rudder in line with this shaft, and then all the other little quirks in the middle of here we do with a 1 foot straight edge, our good quality scale and things like that. And that's how we're going to go about straightening this rudder. Okay, we've got this set up in the hydraulic press here, and we're going to push down on a block right here, right next to this edge. We got it blocked under the center of the blade here, so we get a little bit of pitch here, and we're under the shaft over here to give us that fulcrum or the focus point to put the correction in that section of the blade that we need to. All right, we're going to turn on the hydraulic press. We're going to hold this in place, and we're going to use this as eyeball reference onto bringing the bend out of here. We're going to bring this down to where we're almost contact here. Slide this in position. All right, we're going to make sure our jig is set up in line here. Then we relax. See, it's got to take a certain amount of spring. Okay, we're going to try another little location here in front of this. Okay, where we're pressing at now, we can't put the jig in place to watch it flex. So we're going to give it a push, and then we'll be able to lift it up, and then we'll double check where we're at here. Okay. Okay, we're getting a lot closer. We're going to take it out of here and go put it in a vise so it's standing up vertical, and we can get a really good look at it. Okay, she looks pretty good by eyeball here, and we put our jig up here, and to me it looks, I'm able to flex it up here, and we're just to the width of that web right there on the side, and here we are, we're the same thing right here, within 1/8 of an inch of being in a line. Now I think, staring down that, we got a real nice line right here. She's following in pretty good. Little bit different right here, but that's where that got whacked right there. So I think couple little bends where we're supporting it just each side of that little wafer there, and then our little short straight edge actually shows us that this has a bend right down here at the very bottom where it took that second hit, and we could put this and press this and get that last 1/8 of an inch right there. Okay, hang on, let me kill this fan here. All right, I've got we just moved the chain fall over there. The gantry's here. This is how I lift big things in there. I can't lift this thing up to this height here. I could scoot it on a pallet, or I could push it, I could roll it, I could do, but this is a big heavy chunk of bronze here. Now this strut is bent. When that shaft and that propeller went back, hit the rudder, and then it took a turn, it disrupted the palm of this strut. And I believe also we've taken some straight edge and look at the action of this, and it actually looks like it rolled the hub slightly on the top of here. All right, and it rolled it this way here. Now let's this is how I gauge a strut to be straight, and what I use to bring it back straight. I've taken and cleaned up both edges of the palm. The palm is the flat mounting part of the strut. I got two nice big parallels, and I bring those down in here. Okay, then I take a piece of shafting the size that the bearing is, and I put that in. Everything is gauged center from the palm to the shaft. Alright, now I take a square, and of course this square, normally I use the long and I line my square up with the edge, and I just take my scale and I measure it. Well, I need to have a little bit, this is taller than my normal square usage, so I've taken a key seat rule and clamped it onto there so that I actually have a location that it comes and registers, so we're flat to the parallels and we're sitting here out to this exact edge, and then we can take a pocket scale and we measure over here, and we're 4 inches 50 thousandths, and we come over to this side and rest it against there, and we're 5 inches and 50 thousandths. So that's a whole inch difference. That it's actually only over a ½ inch, but it's a ½ inch away from this side and a ½ inch towards that side, giving it the whole inch measurement difference between what I have here and what I have over here. A ½ inch is quite a bit for something this size. Now, like I said before, I had the straight edge here. I think some of it's rolled over here, but I also have a hollow underneath the palm itself, and that hollow is almost 1/8 of an inch, and it actually tweaks towards one side or the other. So the first thing I'm going to do is I'm actually going to try to take the hollowness out of the palm, and doing that gingerly enough to where I might to bring it back center. So I think it's a combination of both sides of this palm that's actually stretched. Okay, so I can't this is not level right here, so I may not be able to push straight down on here to actually get that pressed back down, because what happened is evidently that when it hit the rudder and it stretched it up, so it pulled the center of the palm out from the hull. So I'm kind of thinking about now I'm going to do that as well. So that's what we're facing up against, and I'll bring you back in when we got a little bit of direction that we're moving to on this. Okay, we started here, we went across here a little bit at a time with this round bar right in the crotch, so we weren't actually pushing against this side, but we wanted to do something to this side without affecting this side here, and that was going to be the first thing, is go ahead and bring this. Now you can see that there used to be 1/8 of an inch in here now, and there's about 80 thousandths there, and at this end here it's almost down to like 20 thousandths or so, and about halfway in between there, about 40 in the middle. So we've gotten most of that valley out just by pressing this side here. I'm going to roll it over, and we're going to do the same thing to the other side. It's kind of nice that this was beveled on here. It kind of gave a place for the parallel to sit in there to let us push that back down flat. Okay, we don't want to curl that over too much there, but there and there is level. Okay, so we picked up as much as we can out of there. All right, now we're going to come over here a little bit. It's touching here, but it's not here. So we're going to try to, we just worked 3 points across here, and that's how we got this other side. And that's flat, and this is flat down here. That's good. That's good. That's good. All right, so we just push this whole thing on over here. And then we hit in the middle here. one more here. This is where I had to put shims underneath the shaft running through the bearing to actually help support this end over here. It moves quite a bit, but we'll still be able to, we got to get just the frog hair out of there. And we got it. With the short straight edge, you can see a nice light hollow right under here, and you also have a light hollow there. So this has got a bow this way here, and this is the side that's far away, and this is the near side. So if we straighten this out here and we bring this in here, we'll be taking out some of this. So we're picking a middle of the road. I have a rock in the middle here, and the other side basically is showing us exactly the opposite, a little bit of a hollow, and more even at the ends there. And so we're going to be, and this is actually kind of taper, so it actually has a little thin spot here, fat here, little thin here, but this side is out in the middle more than this side is over here. So what we're doing is we're going to go ahead and we're going to take scale, and we're looking at this. We're seeing an area right in here. Now when we press down, we're supported underneath our shaft right here, and this side over here is actually loose, and most of the pressure's on this side here. By keeping this semi-level on the squareness here and in line with the shaft, when we press and we do our straightening, this shaft automatically, most of the time, 90% of the time, helps take the twist that's in it this way out. Okay, that's taking, I can see just a little bit of light here. Okay, I'm going to be sliding this way and sliding it that way, and we're going to be working up and down here, and then we'll stand it up and we'll see how much we're able to get out of this. Ha 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 ha! Bigger boat, bigger rock. All right. Just made another rock, bigger base plate. We can draw other patterns, but it fits this one here. And what it does is it grabs a hold of the palm and gives us some leverage out there and twists the palm equally in relationship to the shaft and log. We'll get the shaft in here now. We'll get this set up ready to push and see if we can give that extra 400 thousandths that we need to move that head on over. Just like on the other rock jig that I made, I'm able to mark the center here, equal in the center here, and if this is square and this palm is square and you hold the square up here, okay, this should be at the line. But as you see, and I drew that line there, and that's I eyeballed that line. There's no scientific formula that actually put that Sharpie line right there, but you can see that I am about 400 thousandths lower here. So when we create the right bend and this palm twists down, I should be in line there. All right, and then it would be worthwhile to take it apart and stand it up. Okay, because it is an event to get this into position here by myself without getting hurt. All right, so I think I'm ready to put some power to this thing. And let's see if we can twist that. I'm going to see if I can hold this right here, and we'll watch this line right here. I think I'm starting to see a little stressing in here. I may actually have to add, well, maybe not. Yeah. We did get about half of it. I'm wondering if I'm sitting at that crack in that table, if that might be holding it back from sliding this way here. So I'm gonna go ahead. I'm gonna slide this back that way because we could get this a little bit out here farther, which would give us a little bit more leverage. And I don't know. I'm gonna go get my square, and we're gonna put the square right up here, and we're gonna see if we actually kind of stressing that out there. We have moved it, and this is only 1/2 inch plate here. I just kind of webbed it up like I thought it should be to be strong enough, but I do have a little bit of a void in there, and I could, you know, those could be flexing to the side. That's how I-beam and channel fail if you give it that flex. As you noticed, I had pieced this video throughout the last 2 weeks, and we were heading up towards Labor Day weekend, and it is pretty tough, but it's also, that's where some of the panics were, and sometimes I gotta cut the shit with the videos and hop to the job, so sometimes I lose a little bit of footage. Okay, so I just want to clue you in real fast before we conclude this video here that I did have to add in another web on this and a round bar in here to create enough strength out of this to get this tweaked over, and holding that on that line there, and you can see we were able to pull this on over. And of course I didn't get that on video there because I was between that and getting the work needed to get out so that the customers could have their boat for the weekend. There's priorities in there, and I have to draw the line. So hey, we're walking the talk, and that's what my videos are all about. Now, this jig failed because all I gave it was one bead with the wire feed, and we all know that wire feed doesn't penetrate nearly as much as stick welding. And I took 7018 and I welded it inside and outside, and this is ready to go for another test. The one good thing about that shaft is it's going to remain here, and we're going to continue on. I know a lot of you wanted to see that thing get straight, but hey, I'm showing you my trial and errors for the rock jig for the shafting. We'd like to perfect it as well as the one that works for our struts. All right, till next video, get her done.